The other two, we got to complete the square to solve these. So you're going to rewrite the equation of the hyperbola from general form to standard or graph form by completing the square. Okay, so this time you have to pay attention to what you've got going on. You're going to have either ax squared minus by squared or ay squared minus bx squared. They put the a on this first one. That doesn't really mean anything. Okay, if you have ax squared minus by squared, it's going to come back in the form of this. If you have ay squared minus bx squared, it's going to come back in the form like this. So just have to really watch. A lot of this is going to be very similar to ellipses. It's just that one of your x values is going to be negative. So when you pull that number out, guess what? It's going to be negative. So on this one, we have the 9x squared minus 4y squared. So it's going to get us into more likely this form. I am going to show you an example of it starts out like this, but it ends up being this. But you're going to know when that's going to happen. Okay, so use completing the square to get from general form to standard form of the hyperbola. Again, do not divide by a, move constant to the right side of the equation. So we just got to move this guy over. But I'm going to do step 1 and 2 together, rearrange by grouping. So I'm going to do steps 1 and 2 at the same time. So I have 9x squared minus 54x minus 4y squared minus 40y equals, and again, move this guy over, equals 55. And then in step 3, it tells you pull out numerical GCF only for c of x and dy. So it's just this guy right here. So this is going to be 9 times x squared minus, and 54 divided by 9 is 6x, plus some number. And this time you're going to pull out the negative 4. So minus 4 y squared, 40 divided by 4 gives us 10, but they're both negative, so plus 10y plus some number equals 55 plus 9 times some number minus 4 times some number. Yes, I did run out of room there. So now we're ready to complete the square. So I'm going to come down this way so I can actually move it over a little bit. So I have 9 times x squared minus 6x plus, and then this is going to be 6 divided by 2 squared, so 3 squared, minus 4 times y squared plus 10y, and this 1/2 of 10, so 10 over 2 squared is going to give me plus 5 squared equals 55 plus 9 times 3 squared is 9 minus 4 times, and 5 squared is 25, so 25. Okay, so in this one says write the left side in factored form, which we've been doing all along, and where c is a constant, simplify the right side. So we come over here. So I have now 9 times x squared minus here, so minus 3 squared minus 4 times y plus 5 squared equals 55 plus 81 minus 100. 4 times 45, 100. That's going to get us to a number of 36. So this is 9x squared minus 3 squared. Oh, that's not squared. Wow, I just caught that too. Here I caught it, I didn't catch it here. Here I caught it because I was saying it and writing it. Minus 4 times y plus 5 squared equals, and 55 plus 81 minus 100 leaves us with 36. Next step, it tells you to divide all of your terms by the right side. So I'm going to divide everything by 36. Divide by 36. Divide by 36. And 9 goes into 36 4 times. So I have x minus 3 squared over 4 minus y plus 5 squared over 9 equals 1. And now it is in the format of what we're used to seeing. So again, I don't have the graph that we can do this on, but we can identify everything. The center is going to be 3, negative 5. This guy here is 2 squared. There's my over number. Up, down is 3 squared. And your vertices, 3 plus 2 gives us 5, negative 5. And 3 minus 2 gives us 1, negative 5. Again, x came first, so the x came first, and so we had to make sure we did it that way. 3 plus 2, 3 minus 2. Okay. So, next one. Got a lot going on here. Left everything blank so that we have room to write. Notice that the y squared is first, so we're going to expect it to come down to this one. I'm going to show you why that's not going to happen. Okay, so I have 9y squared minus 90y minus 4x squared minus 24x equals negative 153. Okay, so the next step would be we've got our y's grouped together, is to factor out this guy. So I have 9 times y squared minus 10y plus some number minus 4 times x squared minus 6x plus some number equals negative 153 plus 9 times some number minus 4 times some number. I really hope that I don't need this area here. Okay, that sum number, 10 divided by 2 squared, and this is 6 divided by 2 squared. So I get 9 times y minus 10y plus 5 squared minus 4 times x squared minus 6x plus 3 squared equals negative 153 plus 9 times 25 minus 4 times 9. Actually, this is going to work. I realize I made a oops in my last one. Oh yeah, I did. Oh, I was looking at a different problem. Yep, I did it. Oops, on the other one. Okay, anyways, sorry. So this gives me 9 factored form y minus 5 squared minus 4 times x minus 3 quantity squared equals negative 153 plus 25 times 9, so that's 225 minus 36. So we do the quick math on that, because like I said, I did it earlier, I got the wrong answer. Negative 153 minus 36 plus 225 gives me a positive 36. So 9 times y minus 5 squared minus 4 times x minus 3 squared equals 36. Sorry, I worked this one out before and I got a negative 36. And what that would have done when you divided by negatives would have pulled this guy in front and this guy in back. It's not a big deal. Okay. So on this one here, divide by 36, divide by 36, divide by 36. You get y minus 5 squared over 9 goes into 36 4 times minus x minus 3 squared. 4 goes into 36 9 times equals 1. So now we can identify our center. So our center is 3, 5. Be really, really careful. The x came last. This is 2 squared. This is 3 squared. The y is first. So the x does not change for my vertices. And then this is going to become 5 plus 2, which is 3. Okay, 5 minus 2, which is 3. 5 plus 2, which is 7. Okay, and then we have those. So we can do our rectangles and everything else. So 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. And our vertices are at 3, 3 and 3, 7. And then we're going to go out 3 for the others. 1, 2, 3, and 1, 2, 3. Draw the rectangles. Oops. I lost my thing there. Go. Draw my rectangle. Draw my diagonals. Fix them, make sure they're where I want them to be. That one looks good, that one looks good. Bring this guy down just a little bit. Okay, now remember the y is first, so it's going to do this bit. So we come here, come down, touch the vertex and go back. Same thing on this side, come over, touch the vertex and go back. Okay, so there are 2 more problems on this one that are going to be assigned as the homework problems. More than happy to help you guys if you have questions on these, but you do have that. Okay, so beyond that, I get to say good luck. This is the last of this unit.